first, live, local. This is Fox 12 Now.
Everyone, this is Fox 12 Now. I'm Greg Dibler. As always, we appreciate you joining us. We are live streaming here out of the Fox 12 Oregon newsroom, which is happening there right behind me. And we are, of course, also on our YouTube channel. We're at kptv.com and we're on the Fox 12 Oregon app. So all great places to find us, but you did, and thanks for doing so. Feel free to share these episodes that we have and the conversations that we get to have. Today, we're going to be talking about gene therapy, and in particular, CRISPR gene therapy, and a new study and a showcase about how this could help cure some issues when it comes to the heart. We're going to explain that in a lot better way by having Dr. Ahmad Masri join us right now. Doctor, thank you very much for being here. I appreciate you helping to clean up after my descriptions of what your therapy was. But would you mind starting off there with that and just explaining a little bit about this study and how it got started in the beginning?
Definitely. Thank you, Greg, for having me here today. So, this study goes after a very specific disease that actually affects patients who are above the age of 65 to 70. It's a fairly common disease that we encounter. Its name is pretty complicated. It's called transthyretin amyloidosis. But what that means is that there is a protein that is being produced normally in the body that becomes dysfunctional and causes heart disease. And this is one type of the typical heart failure disease that people hear about, where you become short of breath and you're unable to do the things that you want to do. And in this specific scenario and example, we have had therapies that try to address the disease over the past 5 years or so. But in this new technology and new approach, what's happening is, the body is producing that protein that essentially went rogue and is not wanted anymore. And instead of, trying to, handle it and, try to stabilize it, or instead of trying to chronically dose to try and control it, in this scenario, you can give a one-time therapy that is still under investigation, obviously, in the study, but a one-time therapy that uses gene editing, which is what CRISPR-Cas9 system is. And so it edits the body in the liver where this protein is coming out from, and you prevent that harmful protein from being produced ever again, actually, so far as we know, for a long follow-up period. You don't see it coming out again in more than 5 to 10%. So you essentially are able to suppress the majority of it.
I mean, that's a pretty incredible finding with that high of a success rate potentially of this. So when you're talking about taking that from the liver, this would obviously be very personalized, I would assume, to that specific person when utilizing this gene therapy.
So the good news is that, we all have the same type of protein that's called transthyretin. We all have essentially the same structure of it. And while there are individuals with variation inside the protein itself, the backbone of the protein is the same. So you can use the same technology essentially for every single human being who has that disease. And so our goal right now in such, a sizable, large clinical trial is to show that when you offer this to, unselected large group of people like we are doing, you can still achieve the same results that you saw in a smaller study.
That's amazing. So this could be something that could potentially be widespread for everybody to be able to get this, anybody who's being affected by this particular disease.
Indeed. And again, as I mentioned, it is relatively a common condition. I mean, we're talking about almost 5 to 10% of the patients with heart disease or heart failure above the age of 70, 75, have this disease. And so it frequently is underdiagnosed or misdiagnosed. And for the last 5 years, we have seen a very sharp rise in our ability to pick it up because of the improved imaging techniques that we use, improved evaluation, education at a large scale as well have helped. And so we do have therapies right now that can help with controlling the disease. But this one essentially promises to be a one-time administration of a therapy that can control and prevent the progression of the disease for hopefully ever.
Wow. Would this be something that you would get after you've been diagnosed, or you could potentially even get it before just to prevent that from even happening?
So I think that would be kind of a step down the road. You're really thinking along the lines of how we are thinking, which is in the future, if you are at risk, like if you inherited a mutation from one of your parents and you are at risk of developing this disease, can you at a certain time point, we know this affects people in their 70s, for example, or 60s to 70s and 80s. Can you at some point in the future, use that to potentially prevent it from worsening or developing if you have some minor findings? I think that's absolutely possible in the future.
Amazing. Can you tell us a little bit about this, in particular, the Oregon study and the first Oregon patient to try this out?
Yeah, so this study is a worldwide study, and it is essentially what happens is we have patients who already been diagnosed with the condition. They're already receiving the standard of care treatments that we offer them, and then they get an opportunity to sign up voluntarily and participate in the study. We are the only center, as far as I know, in this region in the Pacific Northwest that is offering access to this investigational therapy at this point in time as part of the clinical trial, obviously not standalone. And we have already had few patients who have participated, and I think you guys have heard about our first patient who got enrolled and dosed in this trial, and there are other few centers around the United States as well who are participating, and we're very encouraged by this because ultimately 7 years ago or so, we had no therapies for this condition. All you could tell the patient is, we'll try to help you with their symptoms and whatnot, but we actually have no way of preventing this from progressing. And now we're at a point we are not just only providing potential therapies, but also providing avenues for where they potentially could just really get this one-time treatment. And so we're very encouraged by this, and we're grateful for our patients, for Oregonians and patients from Washington as well in our neighboring states and California who are participating, because without them, we really would not have been here today.
And when you look at doing this study, and where you're at right now, what does it take to take this to the next level, to get to that point to where this is something that could be available for anyone that would potentially need it?
Yeah, that's part of the good news, is that this is the final step. It took many, many, many years in development to get a therapy like this, because you have to prove that it's safe. That's important. And so, this is the last step, which is what we call a phase 3 trial. So it's the last step where 700 something patients are being evaluated as part of this study. And over the next 3 to 4 years, if we confirm that this is a safe approach and it is essentially effective, and then that gets taken to the FDA, for example, and the FDA reviews all the data over a period of time, and they make a decision to approve or not approve the therapy. And so we are essentially, even though it seems like this is new and cutting edge, essentially we are at the actually final step where we need to prove this and get it to the FDA.
That's pretty exciting to make it to this step so far and see all of that progress. My last question is just, when it comes to the technology side of things, do you anticipate, with the rapid advancement of technology and how that changes even from what you mentioned just a few years ago to where we are now, that things like this can be developed on a quicker timeline?
Yeah, I think so. The FDA also recognizes this, and recently they've come up with some recommendations where they're even willing to consider what's called, platform approaches, meaning we know there are many rare diseases or uncommon diseases that don't affect many, many patients. You don't want each therapy to take 15 years essentially to come to patients. And so the idea becomes that if you use the same approach over and over, but you target different disease, at a time, then maybe they will allow you to actually, progress faster and get faster to where you want to be. So, I think they are very, cognizant of this, and, we're partnering with them as well as with others. And, I really think that the future is bright. And, something that people might not actually know, for what we do specifically, Oregon has been really a leader in this space, where many of the, Oregonians and, in our neighboring state as well have been participating in many of these trials, pushing this forward at a much quicker pace than originally has been.
Well, that's certainly exciting. Anything else that you think is important just for the general public to know about this study in particular?
Yeah, I think, I want to reassure the public that we never, start something unless we know that it appears to be safe to proceed and progress in humans. I think we get a lot from patients, so are we being experimented on? And that's not true. We almost never actually take a step into, working with our patients with these therapies unless we know what the overall outlook is, and if we find anything unexpected, we immediately evaluate and stop or pivot sometimes and do other things. So I want to reassure everyone that we actually do this with a patient-first approach always.
Well, I appreciate the work that you're doing, and it's exciting to find out about this study and, you know, the hopefulness that this could be the fix for so many different people, and eventually maybe something that anybody can take if they're even at threat of potentially getting this. And really exciting stuff. And Doctor, thank you very much for having time to talk to us about this and just explain it and walk it through. I think that's really important to help everybody just understand and educate themselves about this important work that you're doing.
Thank you.
Thank you. And for everybody watching, this is Fox 12 Now. We're live streaming. We're going to take a quick break. We're going to come back. We cover a wide range of topics here on this show, including having in-depth conversations like we just did. So you can find those at all those places I mentioned at the beginning, YouTube, the Fox 12 Oregon apps, and of course, KPTV.com. Coming up at 1:30 p.m., if you were watching live, we're going to be talking to John Legend. We go from heart study to John Legend. So all kinds of stuff that we cover here. And John Legend is going to be here in town on December 9th, depending on when you're watching this. So we talk about that. And we talk about Portland in particular because he does come here, and we cover that. So again, that's at 1:30 p.m. We'll be live streaming on whatever platform you found me on. And I will talk to you then. Otherwise, you can watch it afterward. All right, I'm Greg Nibbler. This is Fox 12 Now.